Today we have discussed about conical pendulum. In rotational dynamics, we have already studied about the kinematics of circular rotational dynamics. Then we have discussed about rotational dynamics. Then we studied about the uniform circular motion, centripetal force, centrifugal force, period, frequency, angular acceleration, angular velocity. Then its applications of uniform circular motion, that is vehicle moving on a horizontal circular path, again vehicle moving on a banked road surface. Here we have discussed about conical pendulum. We know that pendulum, whenever a string, one end of the string is tied on the roof, to the roof, and another end which is held with a bob, and then whenever it just released from that point, then it becomes oscillate. It is said to be simple pendulum. But whenever this simple pendulum, which is revolved in a horizontal circular path, such that bob describes circular motion and string describes a conical path, then it is said to be conical pendulum. तर आपण त्याला काय म्हणतोय, कोनिकल पेंडुलम. समजा एखादा दोरा घेतला, दोरा एका वरती रूफला आपण फिट केलेला आहे. त्या दोऱ्याच्या दुसऱ्या बाजूला एक गोलाकार वस्तू, त्याला आपण इंग्रजीमध्ये बॉब असं म्हणतो. तो जर आपण सर्क्युलर सरळ जर असं सोडला तर त्याला आपण साधा दोलक असं म्हणतो. काय म्हणतो? साधा दोलक. मात्र तो जर आपण समजा जर सर्क्युलर पाथ मध्ये फिरत असेल आणि त्याच्यामध्ये असणारी जी दोरी ती कोनिकल शेप, म्हणजे कोणासारखा आकार जर त्याचा तयार होत असेल तर त्याला आपण काय म्हणतोय, conical pendulum. So here a tiny mass connected to a long, flexible, massless, inextensible string. Tiny mass means small object, point object, which is connected to a long, flexible, and massless, inextensible string and suspended to a rigid support is called a pendulum. तर अशाला आपण काय म्हणतोय, पेंडुलम असं म्हणतोय. आता त्याचं एक्झॅक्टली ती असणारी जी स्ट्रिंग आहे ती स्ट्रिंग लॉंग आहे, फ्लेक्झिबल आहे, मासलेस आहे, इनएक्सटेन्सिबल आहे, आणि त्याच्यामध्ये एक टायनी मास त्याच्या काय केलेला आहे, अनदर एंडला टाईप केलेला आहे, आणि सस्पेंडेड टू रिजिड सपोर्ट. एका रिजिड सपोर्ट पासून तो जर आपण सस्पेंड करत असतो तर त्याला आपण काय म्हणू शकतो, साधा दोलक म्हणतो पेंडुलम. त्याचं साधं सरळ उदाहरण आहे घड्याळामध्ये असणारा तो पेंडुलम. तर याच्यामध्ये कोनिकल पेंडुलम आपल्याला पाहायचा आहे. तर काय आहे, हा आहे रिजिड सपोर्ट, हा काय आहे, रिजिड सपोर्ट. ही आहे स्ट्रिंग, ही आहे स्ट्रिंग. हा आहे बॉब, बी या पोझिशनला बॉब आहे, which is moving in a circular path. हा जो बॉब आहे तो सर्क्युलर पाथ मध्ये मूव्ह होतोय, जेणेकरून स्ट्रिंग which describes a conical shape, so it is called as conical pendulum, such that this string made with the angle theta with its vertical axis CV its center, and here the necessary centripetal force for circular motion to the bob is provided by tension lies in the string. Here T0 be its tension, such that whenever this bob, which is moving in a horizontal circular path, means it performs conical pendulum, then this T0, which is resolved into two components. First one is that T0 cos theta, and another is that T0 sin theta. This T0, which is resolved into two components. First one is that T0 cos theta, which is acting vertically upward direction. Second one is that T0 sin theta, which is acting horizontally direction, means towards the center. This T0 cos theta, which is exactly balances the weight of the ball, that is mg, and this T0 sin theta, which provides necessary centripetal force. You know that centripetal force. Centripetal force means that the force which is acting along the radius and directed towards the center of the circle. It is called as centripetal force. So centripetal force is provided by T naught sin theta, and weight of that bob is balanced by T naught cos theta. So such that here we again give its resolution, component resolution, that is T naught sin theta, which is exactly provided centripetal force. That is centripetal force is mv square upon r mr omega square. This T naught cos theta balances the weight mg. So here two forces acting on that bob which is moving in a horizontal circular path means conical pendulum. First one is that weight mg which is acting vertically downward direction. First one is that weight mg which is acting vertically downward direction, and another is that force T naught which is acting along the string which is in upward direction towards the rigid support. So such that this T naught which is resolved into two components. First one is that T naught cos theta, and another one is that T naught sin theta. So therefore here this horizontal component of the tension, that is T naught sin theta, which is provides necessary centripetal force. So first equation becomes that T naught sin theta is equal to centripetal force. What is the centripetal force? mv square upon r mr omega square. So T naught sin theta is equal to mr omega square. Another is that this T naught cos theta, which is balances the weight mg of that bob. So therefore second equation is given is that T naught cos theta is equal to weight of that bob, that is mg. Here dividing equation number first by second, we can write T naught sin theta upon T naught cos theta is equal to, what is value of T naught sin theta, that is mr omega square. What is value of T naught cos theta, that is mg. Cancel to one another, T naught again cancel to one another. So remaining is that r omega square upon g. But here we have to formulate that omega square. So therefore omega square as it is, this g which is in a denominator goes to the opposite side, which is onto the numerator. So g becomes to the g sin theta. So therefore g going on to the numerator's part. So that is it becomes g sin theta upon here cos theta, and this r will carry to the denominator part. So it becomes r cos theta. So omega square is equal to g sin theta upon r cos theta. So this is value of omega square. So here we can again write this omega is equal to under root, taking square root on both sides. So g sin theta upon r cos theta. So omega is equal to under root g sin theta upon r cos theta. Again here we look at the figure, and here this theta, which is the angle made with the string with its vertical axis. Whenever we are applying cos theta, so sin theta. So therefore this is the L be the length of that string, and whenever we are applying sin theta, so we can write sin theta is equal to opposite side upon hypotenuse. Opposite side means this is a r be its radius, and hypotenuse means it's L. So therefore r is equal to L sin theta. So this equation can be written here, r is equal to L sin theta. What? R is equal to L sin theta. कसं आलं अनेकदा बघा, here theta applying sin theta. Sin theta means opposite side upon hypotenuse. Opposite side r, hypotenuse value L. So therefore r is equal to L sin theta. TBD is the period of the revolution. T means period of the revolution of that ball. So here we know that angular velocity omega is equal to, what is the value of omega? Omega is equal to 2 pi by capital T. So therefore is equal to, what is the value of omega? Under root g sin theta upon, what is the value of r? R ची value आहे L sin theta. L sin theta. R च्या ठिकाणी मी R ची value put up केली. So omega is equal to under root g sin theta upon, what is the value of r? That is L sin theta into cos theta as it is. Sin theta cancel to one another. Remaining is that under root g upon L cos theta. So omega becomes under root g upon L cos theta. So therefore period can be written as We know that the value of the period of simple pendulum is that t is equal to 2 pi under root L upon G. T formula, that is t is equal to 2 pi under root L upon G. So here value of period of the conical pendulum is that t is equal to 2 pi under root L cos theta upon G. T is equal to 2 pi under root L cos theta upon G. So this is the expression for periodic time of conical pendulum. So periodic time t is equal to 2 pi under root L cos theta upon G. Also we can here again find out the value of frequency. You know that frequency means it's a reciprocal of that period. So frequency n is equal to 1 by t. So it can be written as reciprocal of the period, that is 1 upon 2 pi अंडर रूट जो डिनोमिनेटरचा पार्ट आहे तो न्यूमरेटर मध्ये जाईल, न्यूमरेटरचा पार्ट डिनोमिनेटर मध्ये, म्हणजेच काय अंडर रूट जी अपॉन एल कॉस थीटा. सो इट्स फ्रिक्वेन्सी कम्स n is equal to 1 upon 2 pi under root g upon L cos theta. So this is a conical pendulum. What is mean by conical pendulum? It is a tiny mass connected to a long, flexible, massless, inextensible string and suspended to a rigid support. It is called as a pendulum. Whenever this tiny object which is moving in a horizontal circular path and the string describes a cone, then it is said to be conical pendulum. So in such a way that there are some forces acting on that is weight mg which is acting vertically downward direction, there is tension T naught which is acting towards the along the string. This T naught which is resolved into two components. First one is the T naught cos theta which is acting vertically upward direction. Second is that T naught sin theta which is acting horizontally direction. So therefore the necessary centripetal force is provided by T naught sin theta. So therefore we can write T naught sin theta is equal to mr omega square. Again the vertical component, that is T conic theta, which is exactly balances the weight mg. So again we formulate that T naught cos theta is equal to mg, equation number second. Dividing first by second we can write T naught sin theta upon T naught cos theta, mr omega square upon mg, mm cancel one another, remaining is that this g goes to the opposite side at the numerator part, so it becomes g sin theta, and this r will go to the denominator part, it becomes r cos theta with value of that omega square. So omega square is equal to g sin theta upon r cos theta. Also we know that here applying sin theta means opposite side upon hypotenuse, that is r upon l. So therefore sin theta is r upon l, so r becomes l sin theta. Put the value of r, that is r is equal to l sin theta. We know that t is the period of revolution, so therefore omega is equal to 2 pi by t is equal to, what is the value of omega? Under root g sin theta upon r cos theta. What is the value of r? L sin theta. Put the value of r, L sin theta. Sin theta cancel to one another, remains that under root g upon L cos theta. Again we know that the period of pendulum, that is t is equal to 2 pi under root L cos theta upon t, equation number third. And also frequency is given by the reciprocal of the period, that is n is equal to 1 by t, that is 1 upon 2 pi under root g upon L cos theta. Okay, so this is the expression for the conical pendulum.